In the previous video, we had learned about the electronic configuration of elements and the periodic table, that is the electronic configuration with respect to groups and periods. Now, in this video, we are going to be talking about the various types of elements which are present. So, first of all, you have 4 blocks in the periodic table: the S block, P block, the D, and the F block. All of these have a variation in terms of their outermost electronic configuration. I'm excluding hydrogen and helium because they just have one orbit, one S2 as, one S as their orbital which is present, and they can only have 2 electrons at the maximum. So we are not talking about hydrogen and helium. We're talking about the other elements. That is all of these. So these are a part of the S block. These are a part of the P block. These are D and these are F. So you're from group 13 to group 18, excluding hydrogen. They form the P block. Group 1 to group 2, that is 1 and 2 they form the S block. D block is between 3 to 12, and these, that is the lanthanoids and actinoids, form the part of the F block. All of these is with respect to the orbital which is getting filled. So let's start. So the S block elements. So the general electronic configuration for S block elements is either NS1 or NS2. When it is NS1, they are called as alkali metals, whereas when it's NS2, they're called as alkaline earth metals. So lithium, sodium, potassium, rubidium, cesium, and francium are alkali metals, whereas beryllium, magnesium, calcium, strontium, barium, and radium are alkaline earth metals, and these have 2 electrons in their S shell, whereas this has just 1 electron in their S shell. S orbital. So properties of S block elements, they are highly reactive. So if sodium is so reactive in nature that it has to be stored in kerosene to ensure that moisture doesn't touch it. And if moisture touches it, you can see, I don't mean that you should put sodium in water, but there are various videos on the internet which show you what happens when sodium is added to water. It's highly reactive in nature. So these elements are highly reactive. The next is low ionization enthalpy. For now, just understand this, that they have a low ionization enthalpy. I think in the later point in this chapter, when we talk about the individual properties of these groups, and that's when we will be learning in detail as to what ionization enthalpy is. Next, they act as good reducing agents. So first of all, for you to understand the process of oxidation and reduction, oxidation is basically the loss of electrons. Okay, and reduction is the process of gaining electrons. So our elements of the first and the second group readily lose electrons to gain the stable configuration of the noble gases, right? So because it is easy for them to lose electrons, they undergo oxidation readily, which means they are a good reducing agent. So a reducing agent should undergo. So a reducing agent, first of all, is an agent which helps in the process of reduction, which means it itself has to get oxidized. And because these undergo oxidation quite quickly, that's why they act as very good reducing agents. So if you think about it, for you to remember, I've always been confused with oxidation and reduction with respect to the loss and gain of electrons. We've done definitions where you have the loss of oxygen, the gain of hydrogen, all of that. But for oxidation, if I remember it like this, LOE, which means, LEO, which is loss of electrons hyphen oxidation. So that helps you to remember that loss of electrons means oxidation. And since these elements undergo oxidation quite readily, they are good reducing agents. Now, most of them form ionic compounds except lithium and beryllium. Ionic compounds are the ones which are formed when completely electrons are getting transferred. So for example, sodium chloride, Na plus Cl minus. So sodium gives away its electron to chlorine, and so it forms an ionic bond. Next, reactivity and metallic character increases on going down the group. For now, just remember that this is the case. When we talk about the reactivity and the metallic character, the physical properties and all of that, we will, we will discuss that part in detail. Next, the properties of p block elements. So first of all, the general configuration is ns2, which means its s orbital is completely filled, and p orbital is going to get filled, and it varies from 1 to 6. And that's why you have 6 in, or rather 6 groups in the p block. So first of all, the electronic configuration of this group is going to be full. I'm not talking about helium, excluding helium, that is. So neon, argon, krypton, xenon, radon, and organazon, all of these elements, they have ns2 and np6. The value of n will vary for all of them, but the outermost electronic configuration is going to be ns2, np6. And because it's full, they are called as noble gases, and they do not undergo reaction quite readily. Next, you have fluorine, chlorine, bromine, iodine, all of, or rather, group 17 has ns2, np5, and they readily gain an electron, and they are called as halogens. Whereas group 16, oxygen, sulfur, selenium, tellurium, polonium, and livermorium, has the outermost electronic configuration ns2, np4, and they are called as chalcogens. Now the properties, they include both metals and non-metals. Actually, if you notice, you have metals over here, you have non-metals over here. You have the special group of elements called as metalloids in between. About the properties of metals, non-metals, and metalloids, we'll be doing it in a different video. Next, ionization enthalpy is higher than S block. Again, ionization enthalpy, we'll be discussing about it in the coming videos. It shows more than one oxidation state. So this basically means that the number of electrons that each of these elements can lose is not fixed. For example, if I talk about lithium, sodium, potassium, I can tell you that it can only lose one electron, that is the ns electron. But when we talk about these elements, they can either lose one electron, they could lose 2 electrons, and they could have multiple oxidation states, which means they can have many variation in terms of number of electrons they lose with respect to the kind of compound they form. Non-metallic character increases as we move from left to right across a period, and metallic character increases as we go down the group. So again, there is a reason for this. We will discuss about that in the later video. But the non-metallic character, as we notice, it goes from metals to non-metals, so it's increasing. Whereas as we go down the group, the non-metallic character will decrease. So with that, we finish the characteristics of the elements of S and P block. So our S block has the outmost electronic configuration of Ns1 or Ns2, Ns1 belonging to alkali metals, Ns2 belonging to alkaline earth metals. So these elements are good reducing agents because they undergo the process of oxidation quite readily. They are metallic in nature, and they are highly reactive, and they have a low ionization enthalpy. Whereas elements of P block, they have a configuration of NS1, NS2, NP1 to 6. When it's NP6, they are noble gases. NP5 are halogens, and NP4 are chalcogens. And they are P block consists of both metals, non-metals, as well as metalloids. And as we go down the group, the non-metallic character will decrease, and across the period, as we go from the left to right, the non-metallic character is increasing. In the next video, we will be talking about the remaining two groups, that is the T and the F